Hi everyone, welcome to part 2 of the third 9 weeks test review. We are going to go through some of these questions. I won't go through all of them, but I will go through some of them. So picking up at number 13, the population of Sullyville is modeled by the function f of x equals 2,350 times 1.05 to the x power, where x is the number of years since 2010. Use this information to answer questions 1 through 3 below. So they started this in 2010, okay, and they're tracking the population starting in the year of 2010. So it says how many people live in Sullyville in 2010? Well, that's your start value, right? So how many people did we start with? Well, that's this value here in the front, if you remember. So we started with 2,350 people. Is the population increasing or decreasing? And by what percent? So that's where you look at your base. Remember, if your base is bigger than 1, it's increasing. If it's between 0 and 1, it's decreasing. So your base is 1.05, so it's increasing, right? Okay, so how much? So you want to compare 1.05 to 1, and remember this is a percent increase, so this is probably 1 plus some value equals 1.05, right? So you could subtract 1 and solve for r, and that's going to just show you that you get 0.05. Well, what is that as a percent? You move the decimal 2 to the right, so this is an increase of 5% here. So approximately how many people are in Sullyville today? We know it's not 2016 now, but we're just going to go with this. 6 years. So you're just plugging in. So 2,350 times 1.05 to the 6th power. You're going to need a calculator. And you're going to get around 3,149 people. And we would round that to the nearest whole number because the context of the problem is people. Okay. So 16 through 21 is a matching section. This is a little different because you've got expressions here. Do you guys remember the main difference? So equations have equal signs, right? And inequalities can be greater than, less than, greater than or equal to, or less than or equal to. So you're wanting to figure out, equations, expressions, and inequalities, and then you're also looking at linear and exponential, okay? So exponential functions have a variable in the exponent, okay? Just numbers in the exponents don't make things exponential equations. The variable or inequalities, it's having the variable like this here and like this here. The variable in the exponent is what makes it exponential. Okay, so I think you guys hopefully would be okay doing this matching section here. 22 through 24, or 5, excuse me. You're figuring if this is linear or exponential, and then you're writing the equation. I do want to talk about 22. An $18,000 car decreases in value by 6% each year. Whenever you have an increase or a decrease of a percent, that happens to one thing multiple times, it's going to be exponential. Okay, if it's a one-time percent, then that's linear. So like if you go to the store and you buy a shirt or you buy a pair of shoes and you get a discount, that happens one time, so that's linear. When your taxes come out of your paycheck, that's a one-time thing. Okay, but like the value of a car, it depreciates every year. Okay, so that the amount that it's going to decrease is going to depend on the value that it was. So whenever you're increasing or decreasing by a percent each year, that's going to be exponential. Some examples are the values of cars decreasing, maybe the value of a home increasing, or a population increasing or decreasing. Those are generally things that you're going to see represented with exponential functions. So a decrease, that would be 1 minus r. So that will be 1 minus 0.06, which is 0.94. Okay, so this would be 18,000 times 0.94 to the x power for your function there. Okay. Hopefully you guys can do the rest. 23 is not super explicit. Eric can run 9 miles in an hour. Well, that's really just, he's running 9 miles for however many hours that he's going to run. Okay. So that would be 9 times x. That would be linear. All right. So 24 and 25, it's the same thing. 26, you're just labeling these. Remember, y equals a times b to the x power. Okay. So you're just figuring out which is the initial, the base, the time, and the final value there. 27, you're writing these scenarios, or you're writing these equations based on the scenarios, and the key thing here is do not solve. Okay, so some of these are equations, some of these are inequalities, and you've just got to look for the keywords. So an Augusta company pays its employees $35,000. Their pay increases by 8% each year. There's that key right there. As a reward for their hard work. If the company can pay its employees no more than, okay, there's a hint there, no more than $61,000, how many years can an employee expect to get a raise? Okay, so this is an increase by 1%. So I already know some things. I know my R is a percent, right? And I know that this equation is going to look like a times 1 plus, because it's an increase, r to the x power. Okay. So let's see, they pay $35,000 and that increases over time. So your starting value is 35,000. The increase is 8%, 0.08. And it says how many years can they expect to get a raise? That's time. And we know it's no more than 61,000. No more than means less than or equal to $61,000. Okay. We generally put y on the left. Okay. We could put y on the right back here if we wanted to. But if I want to keep y on the left side, if something is less than or equal to 61,000, isn't it true that 61,000 is also greater than or equal to that? So you see, I just switched the order here. If I move the 61,000 to the front, I would switch the inequality sign. Just think of it, if this is eating the 61,000, we kind of sometimes think it looks like an alligator, right? So if your inequality is eating the 61,000 when it's on the right, it needs to eat it when it's on the left too. So less than or equal to 61,000 is the same thing as 61,000 is greater than or equal to something else. Okay, so we just switched the order. My A is 35,000. We said here, I'm just going to do my work here, 1 plus 0.08, that's 1.08. So my base is 1.08 to the x power. There's your equation. We're looking for time. Okay. So number 28, Miss Susan loves watching her garden grow. Her rose bush currently has 7 roses and is expected to triple. Triple means times 3, doesn't it? Each month. How long will it take for Miss Susan to have at least, all right, at least means greater than or equal to 150 roses. All right, when we're tripling, that's a times b to the x. We're not increasing or decreasing by 1%. So I need to know y, a, b, and x. Well, my question says how long, so that's implying time. So I go back. She currently has 7 roses. That's her start. And we're tripling. That's multiplied by 3. And we want to know when will she have at least 150. That's when are we going to end there. So again, if we're greater than or equal to 150, if I'm going to write my y on the left side, I would have 150 is less than or equal to. So the number of roses, that's this a times b to the x, the number of roses is going to need to be more than 150. Okay, so 7 times 3 to the x power. Okay, so 29, just a hint here, depreciates means decreases, so you're going to use 1 minus r for the base for that one. Okay, and number 30, just a hint here, remember with these exponentials, you're multiplying by an amount that you keep. So that's why, like, when you decrease something, if you decrease by 10% and you do 1 minus 0.10, you're left with 0.9. And the base ends up being what you ended with. So if you get rid of 10%, you keep 90%, and that's what you multiply by, is that 0.9. So here, if an organism decays and you keep 1/4, then you don't need to do anything. That just means that your base here is 1/4. You always multiply by what you keep, okay? All right, so moving on. So we want to figure out, are the tables linear or are they exponential? Linear has a constant rate of change. Exponentials have a variable rate of change, okay? And exponentials, you're multiplying by some number, okay? So like in number 31, if you look, it's kind of easy to see from 50 to 25, that's divided by 2, right? Well, we don't write in terms of division, okay? But if you see, hey, I'm dividing by 2, then we can remember, so let's see, 50 divided by 2 is the same thing as 50 times 1/2, okay? So when you divide by 2, it's like multiplying by 1/2. So that's what we would use. This is times 1/2 times 1/2 times 1/2. Y-intercept is what we're starting with here. So 25 times 1/2 to the x power, and that's exponential. Okay. 32, it's kind of easy to see, hopefully. You're increasing by 4 every time. So here, this would be y equals mx plus b. Here's your y-intercept, is 4x plus 30, and that's linear. Okay, so now we're moving into some characteristics. Exponentials always have an asymptote, remember? So the equation of this asymptote is, not x equals, it is y equals 1. Okay, so is this growth or is it decay? Well, it really doesn't look like much of anything, does it? We know that growth is here, and we know decay is this way. Okay, so this one, if we look at 33, it kind of looks like maybe this is reflected growth. Okay, so now let's see, I want to find the rate of change over -2, 1. Remember, these intervals, those are x values. Okay, so I'm looking at an x value of -2. Well, there it is right there. And I'm looking at an x value of 1. So here's where x is 1. I go down and I find the graph. There's the intersection point. Okay, so graphically, if I have a graph and I'm finding the rate of change, I can always, if I'm finding the rate of change over this stretch right here, can't I just do rise over run? Could I say, hey, from here over, this is up 1, 2, 3, 4, 5, 6, up 7, and 1, 2, 3, left 3, which is negative. So that would be -7/3. You could always do that. Algebraically, you could do, you got a point at -2, 0, and you've got a point at 1, 7. You could also do your slope, 7 minus 0 over 1 minus -2. And you get 7/3. It's -7, I'm sorry. -7/3. Your domain, so these graphs never stop from left to right. They're always going to be -infinity to infinity. Your range, remember, is bottom to top. So if you come down here at the bottom, this graph never stops. You can never find the bottom. Down there's negative infinity, and it's going up to 1. The x-intercept is where you cross the x-axis. Negative 2, 0. The y-intercept is where you cross the y-axis. Negative 3, 0, negative 3. X-intercepts and y-intercepts are ordered pairs. Is this graph increasing or decreasing? We always go from left to right, okay? So if I were to stand over here on the left side, what am I going to do as I move down this graph? I'm going to fall down the hill, right? So we're decreasing. Left end behavior is going flat to y equals 1, and the right end behavior is going down. Okay? $34. Assume they have arrows. There's my y-intercept. Is this growth or decay? Hopefully you see it's decay. The rate, there's no interval here, because if you're trying to find the rate when there's no interval, you use the base. Okay, and I'm not going to fill the rest in. I think you can do that. 35 we will talk about though. Okay, so is it growth or is it decay? You always want to look here at these y values. Well, they're getting bigger, right? So we can assume that this is growth, okay? Because they're getting bigger, so I see their growth. My domain, I know these are always all real numbers, but my range, I'm kind of having a hard time seeing what's happening here, okay? So I'm going to come back to that in a minute. Rate of change, oh, I can do this. I can find the x value of negative 2, and I can find the x value of 1. So I have an ordered pair, negative 2, 2.11, 1, 5. So 5 minus 2.11 over 1 minus negative 2. So that's going to give me, so 5 minus 2.11 is 2.89 over 3, 0.96. Okay, so now the rest of this. So what I like to do is make this pen a little bit smaller. I, for these, like to draw a picture, okay? So I'm just going to sketch some points on here so that I can kind of get a feel of what's happening, okay? So 0, 3 is my y-intercept. I can plot that pretty easily. Then 1, 5 is somewhere over here. 2, 11 is probably going to be somewhere way up here, okay? So then I come over here, negative 1 is at 2.33, so that's 1, 2, that's somewhere right there. And as I move to the left here, I'm starting to notice that it looks like these values are getting closer and closer to y equals 2. So as my x's move into the negatives, these are getting closer and closer to 2. So we're approaching y equals 2, okay? So that's going to kind of help me here with my range. Well, from the bottom to the top, I see now, hey, I'm starting at 2 and I'm going up to positive infinity. I also see that since my asymptote is at y equals 2, there's no x-intercept. My y-intercept, I see it on the table, 0, 3. It's a growth, so it's increasing. And now because I drew a picture 2, there's no question. I know on the left, I'm going flat to y equals 2, and on the right, I'm going up. So it always kind of helps sometimes to draw a picture if you need to, if it's kind of hard to see what's happening. Okay? All right. 36. So this is, you start a rumor, and it's going to double in between class changes. So you start with one person times 2 to the x. This is one of these that your domain and your range is going to be discrete. This is a problem where you would not connect the dots because no one is discussing during class, so only during class changes. So after 0 class changes, you're the first person. So you've got 1, and then times 2 is 2, times 2 is 4, times 2 is 8, 16. So 1, 2, 2, 4, 3, 8, 4, 16. Okay, so there's your points. It's growth, and you wouldn't connect the dots because you're not talking in between class, right? So your domain is going to be the x values down here. So 0, 1, 2, 3, and so on. Your range is your y values. So one person knows, then 2, then 4, then 8, and then no one. The x-intercept, none. Y-intercept, 0, 1, and this is increasing. Okay, so 37 and 38 are the linear and exponential comparison problems. So 37, I'll write the equation for you, and then you can do the rest. So Cameron starts with $5 in a savings account, and he plans to double the amount each year. So that's 5 times 2 to the x. So here's your interval. So for this one, you're going to find f of 0, and you're going to find f of 1 and create an ordered pair and find the rate of change. And just remember, whenever you have a graph, you can always go to where x is 0 and x is 1 and do rise over run to find the rate of change for that part there. Okay, hopefully you'll see both of these are exponential. Number 38, so f of x is given here, g of x is here. So f of x, 6 times 2 to the x power, so that would be exponential. Okay, so we can find the y-intercept by plugging in a 0 for x, so 6 times 2 to the 0 power. So 2 to the 0 is 1, 1 times 6 is 6. So this ordered pair here would be 0, 6. Okay, so 0, 6. And then I need to find the average rate of change over the interval 1, 3. So I need to plug in a 1, and I need to 6 times 2 to the first, that's a 12. So this ordered pair is 1, 12. And then I'm going to plug in a 3. So 6 times 2 to the third power. So that's 8 times 6, which is 48. And we get 348. So my rate of change would be 48 minus 12 over 3 minus 1. 36 over 2, which is 18. So that one's done. Okay. So now we need to do the same for g of x. So we need to figure out what's happening. Are we multiplying by something? Are we dividing by something? So one way you can know that you are not multiplying here is because this goes from a positive to a negative, and then they stay negative. So we know a positive to go from a positive to a negative, you would have to multiply by a negative number. And if you multiply a negative by negative, this would need to be a positive if you were multiplying, and it's not. So we got to be doing something. So we're probably subtracting some amount. And if you can't figure it out, you can go backwards. So if we're doing, so this is 5 plus something is negative 7. Negative 7 plus something is negative 19. If you go backwards, negative 7 minus 5 is negative 12. So let's see. Is 5 minus 12 negative 7? Yep. Negative 7 minus 12. Is that negative 19? Yes, it is. So we are subtracting 12 every time. So that's linear. Okay. So the y-intercept, you look at the table. Oh, there it is right there. 0, 5. And for my average rate of change, okay, just a reminder, linear functions have a constant rate of change no matter the interval. Okay, so if you wanted to, you could use the ordered pair 1, negative 7 and 3, negative 31 and find the rate of change. But guess what you're going to get if you did that? Because that's linear, this average rate of change is always going to be negative 12. Okay? So you really don't have to do all that work because the rate of change is the same no matter the interval you're looking at for linear functions. That is not the case with exponentials. So your y-intercept, 0, 6, 0, 5, which is bigger, f of x. Rate of change, 18, negative 12. Well, 18 is definitely bigger. But remember, if that 18 was negative and that 12 was positive, the negative can be bigger because you can decrease faster than you increase. So you ignore the negative signs for average rate of change or for comparing rates of change. Okay? All right. We're getting there. So graphing exponentials. So if you guys remember, so we are looking at the base here is 2. So that's a growth, right? And growth looks like this. Your A here is 1. You ignore the negative sign because the negative means x-axis reflection. A is 1, B is 2. Okay, your initial anchor point, if you remember, is 0A. So that would be 0, 1. Your horizontal shift, you look up here. And we go the opposite direction. So if that's x plus 3, we're going to go left 3. I have an x-axis reflection, so that would take this growth shape and flip it down. And my vertical shift is up 6. Okay, so let's see, the asymptote, we could go ahead and do that. You know, your asymptote is y equals k, so it's y equals 6. So I'm going to go here, we put a dotted line at y equals 6. And then I go and apply it. So 0, 1 is what I start with. Okay, I'm going to give that a 1 just so we don't get confused. So I'm starting at 1. I'm going to go left 3. 1, 2, 3. It's kind of hard to see. And I'm going to give that a 2. And if you wanted to, you could number them 1, 2, 3, and 4 so that you don't get messed up. So it's a 2. Then I'm going to reflect over the x-axis. So your x-axis, remember, is, make this thin. Here's your x-axis right here. I'm going to reflect over that yellow line. Okay, so when I do that, it's going to put me down here. That's 3. Now I need to move up 6 units. So 1, 2, 3, 4, 5, up 6. And that puts me at the final anchor point, negative 3, 5. Okay. I don't know the y-intercept. Be careful. This right here was my initial anchor point. It's not my y-intercept. So I need to plug in a 0 and find that. Okay. So what I'm going to end up with is negative 2 to the third plus 6. So that would give you negative 2. So 0, negative 2, which is down here. So you got to be kind of careful because the points that you're going to connect are these and not the one with the 1 beside it. Okay. 40. So what is A? What is B? So A is 3. B is 1/2. The base tells you decay. There's your shape. My initial anchor point, remember, is 0A. So 0, 3. Horizontal shift, none. Reflection, y-axis. So the y-axis, if you guys remember, so if this is my y-axis here, if this graph was doing this, when it flips over that y-axis, it's going to do this. So if you remember, so the y-axis reflection is going to make my decay become growth, actually. Okay. Vertical shift is down 4. So y equals negative 4. So let's see, 1, 2, 3. Negative 4 is here. So 0, 3 is where I start. Okay. I don't shift horizontally. A y-axis reflection is just going to stay there because it's on the axis, and it's going to then move 1, 2, 3, down 4. My final anchor point is 0, negative 1. Well, that's also my y-intercept. So now I only have 1 point, and what I've got to do is I need to think, hey, this was decay, but I'm not going to do this because it is decay originally, but that negative exponent makes it flip and become growth. Okay, so 41, 42, and 43 are just writing some more equations, determining if you would connect the dots or not based on those. You can check out that answer key if you get confused with those. So lastly, 44 and 45. So number 44, you've been given a compound interest equation with some things already filled in, and you're going to identify each variable. Okay, so my P, remember that's your principal or your starting amount. So that is 355. N is how do you compound. So if you remember, so there's different ways you could compound. So you could compound monthly. That means N is 12. You could compound yearly, or another word for that is annually. That means N is 1 once a year. Quarterly. That means N is 4. Weekly. That would be N is 52 because there's 52 weeks in a year. You always think in terms of a year. So, here my N is 4. That means quarterly. R is your percent. Well, that's above the fraction, so that would be 0.26 or 26%. T is time, so that's 9, and A is your final value, so 3,426.21. Okay, so 45, you are actually doing a problem. All right, so Annie invests $30,000 in a CD, which earns 2.1% interest compounded monthly. Find the amount of compound interest at the end of 13 months. It's asking you to find the amount of interest. We're going to talk about that in just a second. First, I need to figure out how much money she's going to end up with. So what I know is she started out with $30,000. She's going to earn 2.1% interest. Well, that's when you move 2.1% to the left 2 times, you get 0.021. 13 years is your time. And what we don't know, or what we do know, she's compounding monthly. We know N is 12. Okay. What I don't know, is my A. I should make that capital. Okay. So that's what we're trying to find. So when I plug this in, A equals P times 1 plus R over N to the NT power. I get 30,000 times 1 plus 0.021 over 4 to the 4 times 13 power. Okay. Ooh, just kidding. I messed up. Not 4. I was looking up at the top. 12 times 13 because it's compounded monthly. 12 times 13. So if you type this into your calculator all at once, this is what it needs to look like. 30,000 parenthesis 1 plus 0.021 division symbol, not the fraction symbol, make sure it's the division symbol, 4, close it, caret. If you do 12 times 13, the 12 times 13 has to be in parentheses on its own. Okay, that's exactly what it needs to look like in your calculator. So if you do that, you end up getting $39,407.60. Okay, this is the final amount in her account after 13 years. And it's including her 30,000 that she already had that she put in there. Okay, so if it asks you to just find how much money she had at the end of 13 years, that would be this here. Okay, but it asks you to find the amount of compound interest. Okay, so when it asks you to find the amount of interest, a way that what you can do is remember the interest is going to equal the final amount minus the principal. okay? It's the final minus the start. Okay, well, in this case, her final amount is $39,407.60. Remember, that's how much she's got in her account after 13 years. But that is including the $30,000 that she invested in that account. So you would need to subtract that $30,000 out to figure out her interest, and that would give you $9,407.60 for the amount of interest. Okay. I have a question for you real quick. What if I told you we're going to invest $1,000, okay, at, hold on. Let me erase this. I'm going to start over. Okay. So let's say I'm going to invest $1,000 into an account when I'm 21 years old. Okay. I'm going to type this up. Let's make it smaller. This isn't on your notes. This is just something extra. So Mrs. Jones invests $1,000 in an account earning 8% interest annually. She invested her money when she was 18 years old. She decided to take her money out when she was 25. How much money did she have? Okay, so is that something that we could do? So we could, right? So if you thought about it and think about it, you're starting with $1,000. That's not unusual, right? We know that. So A would be 1,000 times 1 plus, okay, 8% interest, 0.08. It's compounding annually. That should say compounded. I'm sorry. I just made this up. Compounded annually, which means n is 1, right? So over 1 to the 1 times, what power? So it doesn't really tell you any time, but you see she invested at 18 years old and she's taking out when she's 25, right? So how long did that money sit? Well, from 18 to 25 years, 25 minus 18 is 7. So the amount of time is 7. Okay, and then you would plug that in. So just something else to think about. One more thing too that is not on this review sheet that I think is pretty beneficial. Don't forget exponential intersections. So while I'm here, I can just write this out real quick. We can do one. So if I told you to find an intersection point, let's see. Let me get a problem. Okay, so what if I told you to find the intersection of y equals 2 to the 2x plus 1 power and y equals 8 to the x? Do you guys remember what you would do for those? So we would drop the y's. We would take 2 to the 2x plus 1 and set it equal to 8 to the x power. That looks like those exponential equations that we've solved before. All right, so you remember you could do 2 to the 2x plus 1 equals 8 is 2 to the 3rd to the x power. Drop the bases. 2x plus 1 equals 3 times x, which is 3x. Subtract 2x. and you would get 1 equals x. Okay, so remember, an intersection is an ordered pair, okay? So if you know an x value, you find y by plugging back in, right? So I could plug in 8 to the first power since x is 1, and I get 8. So remember, if x is 1, y is 8, I get an ordered pair of 1, 8. Okay, so just don't forget the intersections. Those will be on your test too. So good luck as you study.